Hi, I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about algebra. So the question I've chosen to go through is 2017 Paper 1 Question 5 Part A. There's two parts to this question, okay? It tells me that f of x is 2x cubed plus 5x squared minus 4x minus 3. It asks me to prove that x equals minus 3 is a root and find the other two roots. So there's marks going for proving that this is a root, then there's marks going for finding the other two roots. So I think just things like that, make sure you recognize that, right, you should almost in your own head split this into two different things. To prove that x equals minus 3 is a root, you just, everywhere there's an x, you sub in minus 3. And when you do that, you should end up with 0. And everything should cancel itself out. So let's just work our way through that now. Okay, so the first part of this, it's relatively straightforward. Just everywhere there's an x, I sub in minus 3, and I let it equal to 0. And when I simplify it down, I get 0 equals 0. Because you're asked to show, I'd always make sure you conclude. So I put a tick beside it, say that it's true, x equals minus 3 is a root. So because when I subbed in x equals minus 3, because everything cancelled out, that means it's a root. Now I need to find my other two roots. So to find my other two roots, I need to convert the root that I already know into a factor. Okay, so I know that x equals minus 3 is a root. Okay, so what is the corresponding factor? Well, the way you should think about this is to convert a root into a factor, you're bringing the minus 3 back across. Or in other words, you're going to add both sides. You're going to add 3 to both sides. If x equals minus 3 is a root, that means that x plus 3 is a factor. So I get to write. So I know that x plus 3 is a factor. Now to find the other two factors, we're going to divide x plus 3 into our original function, and that'll allow us to find the other two factors. Once I know that x plus 3 is a factor of this, to find the other two factors, I just divide it in. Now you'll notice I always tell my students that there's 4 steps to your long division. My first step is divide. So I'm going to divide the first thing here into the first thing here. So x into 2x cubed will go 2x squared times. And that value goes on top. My second step is to multiply. So I multiply what I have on top by both of these. 2x squared by x is 2x cubed. 2x squared by 3 is 6x squared. My third step is to subtract. In order to subtract, you have to change your signs. So I'm going to change the signs of both of these. So put a minus in there and put a circle around it. Put a minus here and put a circle around it. Draw a line underneath and then subtract. 2 minus 2 is 0. Plus 5 minus 6 is minus 1x squared. My fourth step then is I take down the next term. My next term in this case being minus 4x. Okay? Now we just start the process all over again. So my first thing is I'm going to divide. Divide the first thing here into the first thing here. So x into minus x squared is minus x. Multiply minus x by both of these. Minus x by x is minus x squared. Minus x by 3 is minus 3x. Now I'm going to change my signs and subtract. So put a plus with a circle around it, plus with a circle around it. Minus 1 plus 1 is 0. Minus 4 plus 3 is minus 1x. And then take down my next term, which is minus 3. And again, I'm just going to start the process all over again. X into minus x goes minus 1 times. So minus 1 by x gives me minus 1x. Minus 1 by 3 gives me minus 3. And then I'm going to put a line underneath it and change my signs. So this becomes a plus, this becomes a plus. Minus 1 plus 1 is 0. Minus 3 plus 3 is 0. So the remainder is 0. So what we've actually done as well is we've proved that x plus 3 is a factor. What we've done, if we divide x plus 3 into this and our remainder is 0, that proves that x plus 3 is a factor. Okay? Now, let's look at our answer. The quadratic we have on the top is going to allow me to find the other two roots of this cubic. So what I now need to do is factorize my quadratic, which is 2x squared minus x minus 1. When I factorize this, it's going to give me my other two roots. So if we factorize this, we're going to put a 2x and an x, a 1 and a 1, minus and plus. So my factors are 2x plus 1 and x minus 1. Now, the question is to find the roots. So remember, we have to go further and try and find our roots. So in this case, our roots are going to be 2x plus 1 equals 0, which means that 2x equals minus 1, which means x is minus a half. And the other root is x minus 1 equals 0, which means that x is equal to 1. So the other two roots are x equals 1 and x equals minus a half. So now I know the three roots of my function. In this question, we're asked to find the local maximum and the local minimum points of the function. The function f, which was given to us in part A, which is 2x cubed plus 5x squared minus 4x minus 3. Now, I want you to recognize there's an x cubed in this, which means this is a cubic. It means it has two turning points. So if I was to draw a rough sketch of what this looks like, it's going to look something along those lines. Okay, so I want to find the coordinates of the maximum point and the coordinates of the minimum point. Now straight away you should recognize to find a maximum point or a minimum point or any turning point, the first thing you want to do is get your first derivative. So the very first step here is we're going to find f dash x. The derivative of 2x cubed, well, I bring the 3 in front, so 3 by 2 is 6, and I decrease the power of x by 1, so it becomes x squared. I bring the power in front, 2 by 5 is 10, and I decrease the power of x by 1, so it becomes 10x to the power of 1. Then for this one, this is minus 4x to the power of 1, so I bring the 1 in front, minus 4 by 1 is just minus 4, and I decrease the power of x by 1, so it becomes x to the power of 0. So the derivative of my function is 6x squared plus 10x minus 4. Now, the reason we work that out is because when you differentiate, you're finding the slope. So I know that the slope of the curve is this. Let's think about what the slope is in our sketch here. As the curve is increasing, clearly the slope must be positive. The slope is positive as it approaches the maximum point. As I go from the maximum point to the minimum point, the slope must be negative. All along here, the slope must be negative. And then after the minimum point, I'm going up again, so the slope must be positive. So if you look at just our maximum point, if the slope is increasing before the maximum point and decreasing after the maximum point, then clearly at the maximum point the slope must be 0. And at the minimum point the slope must be 0. So to identify a turning point, you get your slope and you let it equal to 0. Or in other words, you get your first derivative and you let it equal to 0. So I know that my slope is 6x squared plus 10x minus 4, and I'm going to let it equal to 0. So now I just have a quadratic equation that I can factorize. So I can factorize my quadratic equation, and the factors in this case are going to be 3x minus 1 and 2x plus 4 equals 0. So these are my two factors, and now I can find the corresponding x values. So I can say that 3x minus 1 equals 0, which means 3x equals 1, which means x is 1/3. Or I can say that 2x plus 4 equals 0, which means that 2x equals minus 4, which means x is minus 2. So in other words, I know that a turning point exists when x is 1/3. And I know that a turning point exists when x is minus 2. But the question was to find the coordinates of the local maximum and the local minimum point. So it's not enough to just have my x values. I now need to find the corresponding y values. So if I go back to my original function, I can work out what is the value of y when x is 1/3. What is the value of y when x is minus 2? So let's work our way through that now. Okay, so you'll notice that we've recognized from the first part that when x is 1/3, there's a turning point. And that when x is minus 2, there's another turning point. But now I want to find the corresponding y values when x is 1/3 and when x is minus 2. So my original function is f of x equals 2x cubed plus 5x squared minus 4x minus 3. Now remember, instead of f of x in this context, we can just sub in y. Y is the same as our f of x in this context. So when x was 1/3, I just subbed in everywhere there's an x, you sub in 1/3. And if you plug all that into your calculator, you get y is minus 100 over 27. So I know that there's a turning point at the coordinate 1/3 minus 100 over 27. Now we do the same thing when x is minus 2. Everywhere there was an x in our original function, we sub in a minus 2. And when you do that, you end up with y equals 9. Which means I know there's another turning point at the coordinate minus 2, 9. Now, in the majority of these questions, you have to go further and prove which one is the maximum and which one is the minimum. In the marking scheme for this question, they didn't actually require you to prove it. They required you have to be able to identify which is which, but they didn't actually require you to prove it. Now in this video I'm going to prove it because this is the exception to the rule. But I want to show you just to get the marks in this question what you had to do. To get the marks in this question you have to recognize which one is the maximum and which one is the minimum. Well, the key, you can actually tell by looking at them which one is max and which one is min. Because just think about it. The coordinate -2, 9, well let's say if my x value is -2 here and my y value is 9, that means this coordinate is roughly there, somewhere along there. Whereas this coordinate is 1/3 minus 100 over 27. My y coordinate is negative, so it's down below the x-axis somewhere. So clearly the coordinate that has a bigger y value must be the maximum point. So I know that -2, 9, to get the marks there, you just had to say that the max was -2, 9, but that the min was 1/3 minus 100 over 27. That was the marks for this question. However, that is usually not sufficient. So if you had this question in the leave insert, I'd really encourage you to go further. So let's talk about now how you would actually prove which one is the maximum and which one is the minimum. I want to just be clear. For the marking scheme in this question, this actually wasn't required. However, 9 times out of 10 in these questions, this extra conclusion is required. So I would always expect, if you're asked to get a maximum point or a minimum point, you should always finish it off like this. I know that there's a turning point at the coordinate 1/3 minus 100 over 27 and at the coordinate -2, 9. In the previous part of the question, you worked out your first derivative was 6x squared plus 10x minus 4. You now want to go further and get your second derivative. So your second derivative, f dash dash x, is 12x plus 10. In order to investigate whether a coordinate is a maximum point or a minimum point, you sub the x value into the second derivative. So my second derivative is 12x plus 10. Instead of, I want to work it out when x is 1/3. So instead of x, I sub in a 1/3. And when I plug that in, 12 times 1/3 plus 10 gives me 14. So I would conclude by saying the second derivative is greater than 0, so that means it's a minimum point. So if you sub in the x value and the second derivative is greater than 0, you can conclude that you've got a minimum point. As opposed to the opposite happened when we subbed in x equals -2. When I subbed in x equals -2, I got 12 times -2 plus 10, which is -14. So in this case, I worked out that the second derivative was less than 0. If the second derivative is less than 0, that means it's a maximum point. So it's probably the opposite of what you would think. If the second derivative is greater than 0, it's a minimum point. If it's less than 0, it's a maximum point. Now, the majority of questions in the leave insert, if you're asked to find a maximum point or a minimum point, assume that you have to do this. And even in this question, you would assume that you'd have to do it and you'd work it out. So you can actually tell by looking at them which one is the max and which one is the min. I could tell that this is the maximum point straight away because the y number is bigger, basically. But that's not sufficient. I want you to make sure you get into the habit for max or min questions, always prove it by getting the second derivative and subbing in your x value. Okay, so I hope this made sense. We're now going to move straight on to part C because part C is directly related to part B. For the third part of this question, you could just write down your answer. There's no work to be done. But I want to just describe to you what we've done. There's a lot of understanding to answer in part C in this question. In the first part of this question, we worked out that the roots of this function are -3, -1/2, and 1. In other words, the points where it crosses the x-axis are -3, -1/2, and 1. In the second part of the question, I worked out that there's a maximum point at the coordinate -2, 9. There's a minimum point at the coordinate 1/3 minus 100 over 27. And seeing as the last number, the constant in our function is -3, I know that it crosses the y-axis at the coordinate 0, -3. So I actually know a lot of information about my curve. I can draw a pretty accurate diagram of my curve. Now the next part of the question says, find the range of values of a for which f of x plus a has only one real root. Okay, first of all, if a question asks you to find a range of values, that means your answer is an inequality. Range is another word for inequality. So what number do I need to add or subtract to this graph in order for the function to have only one real root? Well, there's two separate scenarios in this case. There's two separate answers. So let's consider, right, scenario 1. Right, so my cubic can only have one real root. But every cubic has 3 roots. Regardless of what you do, no matter what I do to the function, it will have 3 roots. If it has one real root, the other 2 are going to have to be imaginary. They still exist, but they're complex numbers. So in order for this function f of x plus a to have only one real root, one of the possible scenarios is that it looks something like this. That it only actually crosses the x-axis once, and that basically that the minimum point is above the x-axis. If the minimum point and the maximum point are above the x-axis, that means it only has one real root and 2 complex roots. So I need to ask myself, what would I have to add to this function in order for the minimum point to be above the x-axis? Well, I know the distance from the minimum point to the x-axis is 100 over 27. The distance from here to here is 100 over 27. So if I added a number that was greater than 100 over 27, then my minimum point would be above the x-axis. And my function f of x plus a would only have one real root. So your first answer is if I added a number greater than 100 over 27. So your first answer is just that a is greater than 100 over 27. Because that means the minimum point would be above the x-axis and I'd have this scenario. Okay, so that's your first answer, but we have 2 separate answers because clearly there's the opposite could occur. So rather than the minimum and the maximum point being above the x-axis, the minimum and the maximum point could be below the x-axis. So what about if I had a scenario that looked like this? In this scenario, my function f of x plus a has only one real root. It only crosses the x-axis once. So now my minimum point and my maximum point are below the x-axis. So in this case, I need to ask myself, what do I subtract from my function in order for the coordinate minus 2, 9 to be below the x-axis? Well, clearly, if I subtracted a number that was greater than minus 9, if I subtracted a number less than minus 9, so if the number that I subtract is less than minus 9, so if a is less than minus 9, then that means my coordinate minus 2, 9 would be below the x-axis. And I would have this scenario where I've only got one real root and 2 complex roots. So you have 2 separate answers in that case. If a is greater than 100 over 27, I'd have this scenario. Or if a is less than minus 9, I'd have this scenario. I think a lot of questions have come up on cubics like that where you really need an in-depth knowledge about the coordinates, the roots, what constitutes one real root or 2 real roots or 3 real roots. The key to any of these difficult questions is always just to draw a nice graph. If I hadn't drawn that graph, it would have been impossible for me to explain this question to you. So if you don't draw this graph in an exam, it'll be impossible for you to figure it out. So as always, I hope this video made sense. If anyone has any questions on that, just ask me in class during the week or send me an email and I'll try and explain it differently.